Completing the square to find the zeros of a quadratic function. I understand. Now, the first thing I want to say about this, can you hear my voice slow down? It's not because I'm scared of this lesson. It's because I have to be careful and say just the right things to help you. And like I say, you really want to copy all this down as I'm going through it and have a copy of it. But I will post the completed version and the video. Like, it'll all be there. The first thing I want you to notice is the title says completing the square again. If you've taken the attitude in grade 10 and the first few sections of this, they're like, I don't really like to complete the square. That's not really my thing. I never really got into that. That's not going to go well at all. Like, for instance, on your upcoming quiz, which I'll give you some details about as we go along here, there could be a question called complete the square to find the vertex. Then there could be a word problem where to get the answer, you have to complete the square. And then here, you might have to complete the square to find the zeros. Do you see how, like, you could get a really low mark on this upcoming quiz if you can't complete the square? So more practice today. And I'll teach again, like, I'll be talking to people that are like, I'm still not very good at this. That's who I'll be talking to when I'm teaching. If you're good at it, you're going to be bored at times here as I complete the square. In the previous lesson, we used factoring to solve quadratic equations. And it might have left you with the impression that anytime I get a quadratic equation, I can just factor it. And that is not true. We have to pull away from that. Grade 10 would mostly leave you with that impression, that we were looking to factor this thing. In the cases where the expression does not factor, okay, all the way through 10 and through the first few chapters of 11, we made everything factor. And so it was like, oh, it works out. There is two numbers that say multiply to 8 and add to 6. And every time there was these two numbers. And you were very kind about that. You didn't put up your hand and go, what if there isn't two numbers that, what if there's no two numbers that do it? Here we go. That's what today's about. And tomorrow, or Monday in our case, yes? So what if the expression does not factor? For example, 2x squared plus 8x plus 5. If I go through this and go through all the combinations, I'm going to put them all up here. And it doesn't matter if you use decomp or use magic x, you're going to run into the same problem I'm going to run into here. Where I'm going to go, well, okay, so maybe it could be 2x and x, and maybe this is 5 and 1. And if you multiply that out, you get 2x squared plus 2x plus 5x plus 5. And that's not correct. That doesn't expand out to 2x squared plus 8x plus 5. So you go, oh, well, I must have the 1 and 5. I must have them backwards. I must have them the other way around. I must need to do it the other way. So you do it the other way. You go, oh, 2x plus 1, x plus 5. And you expand that out just to check it, and you go, it doesn't work. And there's no other factors of 2 to consider, and there's no other factors of 5 to consider. And you're like, so that's a major league problem. In fact, most things don't factor. It takes a teacher teaching you 10 academic or 11U to make up questions that nicely factor. All right. In cases where the expression does not factor, we can use the technique of completing the square. And if you've been completing the square and seeing that, it's like, isn't that for max mins? How's that going to help here? Well, then I got to rewind. This next 5 minutes is why you came in today, is to understand something very big about solving equations. Let's talk about grade 9 for a second. At the end of grade 9, you were left with only one phrase for solving equations. It seemed like the whole strategy was isolate x. In fact, you might have been left with the idea that solving equations was actually pretty easy. You get the x's on the left and the numbers on the right. And even if it was fairly complicated, I'm just doing this in one of my other classes right now. Something where there's x's on both sides and numbers on both sides. This is very scary in grade 9. Here comes the wisdom in grade 11, though. The wisdom. There's only one type of x term. There's only x's. with only one type of x term, isolate does work if there's only one type of x term. And what you do is you get, oh, let's get the x's all together on one side. Let's get the numbers all together on the other side. And then the final step is often division, and you're just isolating x. Then I'm going to skip in between. You might want to take a second and not copy for just a second. Then you get to grade 11. And the game changes. The game last day was this. There's the equation we want to solve. And a completely different approach comes in. You're like, no, can't isolate x. There's two different types of x terms there. How are you going to isolate it when there's two different types there? It seems impossible. It looks like, well, could you possibly use the isolation tactic anymore? Well, the answer is you can't. We learned factoring. That is, a quadratic, many quadratics can be factored into two different factors, each of which could then be 0. And then I could use isolation. I could go, OK, x plus 5 equals 0, x equals negative 5. Now here comes the wisdom. That is, I'm not just memorizing what someone's told me to do. I understand why we're doing it. Why we're doing this is it allows us to break it into two x's that are the same type of x. There's an x, x plus 5. There's an x, x plus 3. Those aren't, the x squared seems to be gone. It's not gone. But I've broken this into two pieces.
Yeah. There's one question that was kind of weird.
There always is. So why have I left a gap between here? Because there is a type of question that I've left out in all this. And I'll call this in between, I'll call this because this might rock your thinking a little bit. And hopefully by the time I finish, it'll become clear what the heck is going on here. Because then by the time I'm done here, you go, OK, if it's x, isolate. If it's x squared, factor. That's not bad. That's fairly wise. It's not quite complete yet. Here it comes complete. Do you remember this fun thing? From grade 9. Well, actually earlier, maybe. Maybe grade 7, grade 8, depending on what school you went to and what teacher you had. So sometimes they do it earlier. It doesn't matter if they did it earlier. And then you get this. And the wisdom we just said was if it's squared, factor it. We didn't factor that. We just solved. In fact, we isolated there. And that can rock your world in the middle of this chapter if I'm not careful and explain this carefully. That's why my voice is slowing down. Be careful to explain this to them. Let me repeat what I said. I'll rewind the video for a couple of sentences that happened earlier. If there's only one type of x, you can just isolate. Whoa. This lesson's in 3D now. I threw a pen at you there, Benny. Let me repeat that. If there's only one type of x, you can isolate. If there's multiple types of x's, x squareds and x's, different powers of x, to put a couple of technical terms in there, you're going to have to factor. That's the wisdom so far. How does this fit into all that? There's only one type of c here. So isolation was fine. That's why we could deal with squareds there. The issue is right here. As soon as you see x squared plus 8x, you're like, oh, here we go. I can't isolate anymore. I'm going to have to do something else. What could I do? I could factor. That's what you did in Wednesday's homework. You could factor. And today I'm suggesting complete the square will also solve these things, leading to something even more powerful the next day. Whew. A lot of pressure there. Do you have any questions? That needs a sentence afterwards. And if you haven't been copying, now's the time to get all this down. If there is only one type of x term, you can isolate. Now, why did I hesitate there? You can ignore everything I say next. I'm not going to write it down. There is situations coming in future math where it may be difficult to isolate depending on the situation. But I'll stick to my wisdom. I'll say we should be able to isolate. If there's only one type of x in the whole question, we should be able to isolate. More wisdom on that coming later. But for our purpose in grade 11, this is wise stuff. I'll underline that in gold. That's orange, Mr. Todd. It's gold. This is a gold sentence. That can go on the top of your study sheet for this chapter. There's only one type of x, isolate. Do you need more time there? Okay, after all that, you should be like, well, yeah, what's that? I still don't know what that has to do with complete the square. I'm like, yeah, I know, I'm not done. That's part 1 of the lesson. Part 2 of the lesson, it says, all right, what's going on with my screen there? Bring this over here. Make it a little smaller. It says something very scary. Solve the following quadratic equation. Express answer as exact roots and as approximate. Okay, I'll get to all that. I'll deal with the fractions, the decimals, as I go along. But this lesson says you can do it by completing the square. Okay, you look at this and you go, okay, the wisdom you just gave me that says 2x squared plus 8x plus 5, there's 2 different types of x terms. I should have to factor it. There's not one type of x term. I'm going to complete the square and go through those steps and explain it. I'll get sidetracked for a minute and teach all the people that maybe aren't caught up on their homework because maybe they're getting distracted by their phone or whatever is going on in their life.
Sorry,
Yes?
I'm doing English, Mr. Ron, I'm sorry.
You just neglected your class. He said his other class is more important than this.
So I'm going to complete the square even though it looks like, why are you completing the square? And then there's a aha moment coming, okay? So for now, I'm just teaching complete the square again if you're behind on complete the square homework. Here's the procedure of complete the square. Step 1, I'm going to write the steps. Step 1. Not in gold, red. Step 1. Factor off A from first 2 terms. Again, as promised, I'm teaching the people who are a little behind here. Those of you who are completing the square maniacs and have been doing your homework, you're like, yeah, what? Why are you over-explaining this? I'm trying to get everybody in here for our upcoming quiz. So I just take this 2 and I factor it off those first 2 terms. It is not wrong to factor it off all 3 terms. It's just a waste of time. I only need those first 2 terms. Step 2. Add and subtract b over 2 squared. I'm trying to write it in as few words as I can. I'm not trying to do these long sentences. And most people I know, to get the magic number, go over here somewhere up in the top corner. I don't know why we do it like this. I think as teachers do it, so then students do it. They go over here and they go, okay, b over 2 squared. And here b is 4 over 2 squared, which is 2 squared, which is 4. Somebody raises their hand and goes, wait a minute, b was 8 in the original question. I'm like, yeah, okay. Technically, I should have wrote the new b. The b I've got now, not the b I had before. Yeah, that's why I factored the 2 up. So, 2 bracket x squared plus 4x plus 4 minus 4. Completely wild step. This procedure figures out the number that if I had it would complete the square. What do you mean complete the square? I'm looking for 2 numbers. If I'm going to factor those first 3 terms, I'm looking for 2 numbers that multiply to 4 but also add to 4. What 2 numbers multiply to 4 but also add to 4? 2 and 2. See, the same number. If you've done this right, this makes you a trinomial that exactly factors as a square. So this is 2 bracket x plus 2 squared. So this is step 3. factor. Then I'm going to write something mysterious. We'll need somebody who has done their homework to explain this number, because everybody's like, as soon as I write -8 here, there's somebody that goes, -8? There's no 8. There hasn't been an 8 in this question for a while. Where are you getting the 8 from? And I'll get that information for you in a second. But notice, factored as a square. That's why it's called complete the square. Oh, let's open the title. Complete the square. I've completed the square. I've made it into a square. Where did the 8 come from?
The 2 times -4.
Yeah. A mark on the quiz just for doing that. Just to draw that arrow, because I know that's the number 1 error. By far, not even close, in complete the square. That's the error most people make. And then we pause. That part of the lesson was completing the square again with a medium one. A medium one is one where you factor it off, but no fractions came up at all. You're like, actually, I'm pretty good at that. Then you should be pretty happy right now. If you're like, the fractions are still killing me, Mr. Yeah, I know. That's going to take some time, but hopefully this was a medium one to start off with. Like, well, okay, that's not bad. Hopefully. If it isn't, if that's really bad, it is, I give you permission to panic now. It's time to panic. It's time to have math on your list every day and go, I got to complete the square every day, a few times. Now we come back to this lesson and go, why do I care? Why does complete the square allow us to do this? Because my problem was there was different kinds of x's in the original question. There was x squareds and there was also x's. So to isolate was impossible, it seemed. I might have even said that. To isolate is impossible. And when I said that, when there's 2 types of terms, you cannot isolate the x. Complete the square was on the bench going, I can do it. Here, let me show you. Complete the square. Now there's only 1 type of x. Now you can isolate. The rest of it is just isolation. That is, if the grade 9 version of you showed up today and I went to explain the remaining steps, you'd be fine with the remaining steps. I'm not saying they're easy, but I'm not going to do anything crazy here at all. And I'll do it slowly this time. In other questions, I'll do this next part quickly, because I hope once you get to there, you're like, oh, okay, call Pizza Hut, order the pizza. I'm going to be done this in just a second. I'm going to bring the 3 over. All I'm doing is peeling back the layers now. I'm digging x out of there. It's buried inside, but there's only 1 of them now. There's only 1 type of x. Going to divide by the 2. Now I'm going to make a mistake. Not a mistake. You can copy it. An omission. And we'll need somebody clever to help me with my omission. Okay? Plus or minus square root. Yeah, we led you astray, unfortunately. We didn't know what else to do. When we were teaching Pythagorean theorem, we didn't do plus or minus because we're talking about a side length. We don't need the negative. But technically speaking, there's 2 numbers that square to give 25, plus or minus 5. And now we care because we're graphing. Positive and negatives are in, so we have to deal with that. And then I move the 2 over. I put it there out front because I've ran into this a lot before, so I like the number out front of the root. It's not wrong to write it the other way around. It would not be wrong to write plus or minus root 3 over 2 minus 2. That is not incorrect. I think you'll like this better moving forward. It's not clear why I would like it better there. That's the end of the procedure. Now, and I say this in calculus like every day, after the procedure, then answer the question. Now go back and read the question. Go, did I give it the way they asked for it? It says, express answers as exact roots. I did that. Exact roots. I didn't go to decimals. I just kept it as roots. And if you want to ask the question in a second, why can't we just use decimals? It's a very good question, and I'll be glad to answer it in just a second. But then it says, and as approximate roots to the nearest hundredths. So it's giving you permission, saying, go ahead and get the decimal version of this, because it depends on the situation you're in. Maybe you want the decimal. So I've got 2 different answers here. X equals -2 plus square root of 3/2, or x equals -2 minus square root 3/2. And I encourage you to plug this into your calculator as well and see what these two things are, just to make sure you got that down pat. I've been in a heavy calculator loaning week this week, so I think I'm all out of calculators. I know what I'm doing tonight. I'm going on Amazon. I'm ordering some calculators. That's an exciting Friday night to me. Now I got to use this old school one. Plus, do I even know how to use this piece of junk? -0.78. You type it in and see if you get the same as me. Just so I know I'm using this ancient calculator correctly. And I get -3.22. Did anyone else get that when they typed in their calculator? And a good calculator like the Casio? Yeah, it's good. For the record, there were two numbers that multiplied together and added. It could have factored if I was smart enough to come up with the numbers -0.8 and -3.22. So technically, there are two numbers that would have got this to factor, but you're never going to come up with them, and that's why procedures like this exist. Woo! What questions do you have about that? Crazy question. I hope I've struck fear in the hearts of people who cannot complete the square. Fear is good right now of complete the square. You're like, the first thing I got to do is go and do a bunch of completing the square. And if you're going to go do it, start with ones without a coefficient. And just do a couple of those. Don't try and redo all the homework. Then start with a couple with a number out front. Then delve into fractions as much as your emotions will allow. Yeah? Get yourself a box of Kleenex and just work your way through. I know the fraction ones are hard. I'm aware. Yeah? I emailed some people yesterday. A couple people emailing me about the fraction situation. I send them the fraction, like, oh, what about this? Oh, that's common number. It's hard to keep all that stuff straight. Do you have any questions? I'm not sure. I believe now I just do it again and again. I just keep repeating that procedure, trying to hammer it home. Ben?
Number 2. What and why is like nothing negative? Positive right-hand bracket. Is that where that 2 is coming from?
This 2 out here.
Oh, it's that one.
Is it okay? It's a good question. So don't let me, I'll sort of act like, oh yeah, then we're fine. Once we get to here, once we complete the square, I'll just be like, okay, the rest is easy. I'd say it's easy. It's just not the point of today's lesson. Today's lesson is the complete the square part of it. And the big deal here is completing the square gets us down to one type of x, allowing isolation to come back in as a strategy. My next question is, would you rather factor or do this? And for most people, it's, I'd rather factor. I better check that first. If it factors, that's what I want to do. Because this is long and crazy. But long and crazy and the same every time. It's so repetitive, it's ridiculous. So if you go home and do your homework and the first one's like, I can't do this at all. Then you do the second one, this is still terrible. And then you do the third one, like, oh, all right, I'm kind of getting this. Fourth, fifth, you start to get it. Right? That's why I'm just repeating it in the note. More time here? What's going on with my screen today?
I'm locked in that.
2x squared minus 5x minus 1. Same exact steps, except if you've done a few of these, you might already be able to see what's about to happen here. Badness. Badness, yeah. Step 1, common factor, the leading coefficient it's called, the a value, off the first two terms. And if that, as I say that, you're like, it clicks a little bit. You're like, yeah, because it's so repetitive. The steps are identical. They're very difficult steps, except they're identical every time. 2,
That was the driest cup ever.
and it's not wrong. to take the factor off the 1, you're just making a mess. Just leave it out. Step 2, take half of your new b value and square it. Also difficult, but very repetitive. Every fraction question does the same things over here. You go over and go, okay, take negative 5 over 2, divide it by 2, and square it. And if your brain has just clicked off, you're like, nope, fractions, not doing it, I'm out. Don't let me try and convince you fractions are okay. That's okay. But just check out this fraction work, because some fraction work is very difficult. And some fraction work actually isn't once you get what's happening. And if you just follow along with me here, I hope you'll find that this isn't the worst fraction situation ever. And there's some shortcuts. When I'm dividing by 2 with fractions, I'm actually going to multiply by 1/2. There's 2 reasons for that. One is that's what they told us to do. When you're dividing fractions, you multiply by the reciprocal. So 2, which is 2 over 1, I just flip to 1/2. Also, it just makes sense. If I said to you, take $100 and divide it by 2, that's the same as finding half of $100. So dividing by 2 and multiplying by half is the same thing. So that sort of fits here. So it doesn't have to be crazy fraction thinking here, multiplying by the reciprocal. It can just be dividing by 2 is like multiplying by 1/2. So then I get negative 5 over 4 squared, which is 25 over 16. I just have to square the top and bottom. Is that easy? No. But it's the same steps every single fraction complete the square question. Oh, that's a sentence. Every single fraction complete the square question. So you go back over here and you go, I've got my magic number now. Plus 25 over 16 minus 25 over 16. Apparently that is the magic number that now this thing will factor as a square. Now, once in a while, multiple people send me the same question, so I copy and paste. I sort of feel guilty when it happens. Somebody asked me about this exact situation yesterday, and then 3 other people asked me the same question, so I just emailed me the stuff I sent other people, so it worked out really nicely. I didn't even have to pause the show I was watching. How are you supposed to know how this thing factors? And I know 4 great ways to know what goes in the brackets. It's going to be something squared. And the question is, what is the something? The first way is it's right up there. And that might seem random to you, or it might seem weird, or a crazy coincidence, but it's not. It's not weird at all. That's the number that gets squared. It's the number that multiplies by itself to give 25 over 16. So if you just look over here, you might be like, well, what number multiplies by itself to give 25 over 16? And your work over here is going, I know what number multiplies by itself to give 25 over 16. It's the negative 5 over 4 that you have. And negative 5 over 4 plus another negative 5 over 4 is negative 5 over 2. So you don't have to overthink this. The work is right there. That goes there. Okay, you're like, all right. Starting to get my attention now. I'm starting to go, maybe this isn't quite as impossible as I thought it was. This 2 multiplies by this. And that fraction work also is not the worst fraction work ever. Because you're just multiplying by 2. So you multiply the numerator by 2, you multiply the denominator by 1. Incidentally, the 2 does get multiplied by everything. Look at the 2's already out there in front of this stuff. Nobody really forgets to do that usually. It's already there. Now, almost done. The complete the square part of this. I like reducing the fractions. I'll automatically reduce fractions anytime you let me because it makes the question easier for me. So it's worth my investment to go, does this reduce? It often does. And so this can be reduced down to negative 25 over 8. Now let's just talk about 1 for a second because I want to combine it with the 25/8. So I need to convert it into a new 1, which I'm going to call 8 over 8. That really bothered some people yesterday. But I'm just getting a common denominator. And when it's a whole number, all you do is go picture it over 1 and multiply top and bottom by whatever you need to make it into the denominator you already have. Then I'll stop completing the square because I'm now done. I'm now done completing the square. And listen, if you're not asking for an iPad for Christmas, I don't know what the heck you're doing. This is what iPad people do on these notes like this. Like, oh yeah, I'm sort of done with that. I'll just whoop, whoop, doo, doo, doo. It's there if I need it. I can resize it back up if I need to look at it. My crazy son used to do a whole page of homework on one page in his iPad because every time he was done a question, he'd just go whoop and put it up in the top corner, whoop, 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 and then his whole, he could look at a whole page of homework. I couldn't do it. It would mess me up, but he liked it, iPad gives you these possibilities. Okay. So Todd, do you work for Apple? No, Casio. All right. My brain's hurting. You're saying? What have I accomplished by completing the square? In terms of this lesson, why is this so much better than this? One type of x. See? Listening. One type of x. That's what complete the square accomplishes. So now you can know, why do we complete the square? To get it down to one type of x. The rest is isolation. So I'll go a little bit faster. I'm not trying to rush the lesson. I'm not trying to assume that you know this stuff. I'm just trying to say, okay, that maybe needs a little less explanation. And the steps are the same. You bring over the constant term. Was negative 33 over 8. Now it's positive 33 over 8. Then divide by the 2. Oh, and you're like, here we go with the fractions again. Oh, I know, it's the same. Divide by 2. How do we divide fractions by 2? Yeah, change it into multiply by the reciprocal. And if your mind is just starting to open up to fractions again, where you're like, wait a minute, I know in my brain that fractions are pain. Check these ones out though. Look what happens. 33 over 16. Is it possible to know that was coming? 33 over 8 becomes 33 over 16? You're just dividing these fractions by 2, so you're making twice as many of them. You don't have to understand that, but it's just interesting that that plays out the same way every time. I will bring that over. Right now I'm bringing the squared over because I'm peeling the layers back here. So square root plus or minus square root. And this happens once in a while. I'll just write it, and then you take a look and see what you think. Sometimes one of the two will be a perfect square, and you can go ahead and do it. Last step, almost last step. This. Scroll down a little bit there. Let me know if you need me to scroll back up again. And actually, these are the same denominator. So now I can write it as, if I wanted, I could write it as 5 plus or minus root 33 over 4, which might be triggering something in your brain from last year. What is it almost? Does anyone remember what this is almost? It looks and feels like the quadratic formula because it is the quadratic formula. When we do learn the quadratic formula, all the quadratic formula says, aren't these steps the same every time? Couldn't we just get somebody really clever just to do the steps with the A, B, and C and end up with a formula of this? And that's exactly what I'm going to do, is just go, hey, let's just shorten this procedure down and jump all the way to the end if you're willing to memorize the crazy formula. Yeah? Did I answer the question? I already forget now. See? What did it say? Before A. Solve the following. I did. Express answers exact roots. I did. Yes? I did that. Oh, and roots to the nearest hundredths. Oh, okay. So x equals 5 plus root 33 over 4. or x equals 5 minus root 33 over 4. And never, you're not going to want to use, like, I grew up on one of these pieces of crap. This is how we got through high school. So I know how to type this thing in to get the answer. But geez, might be time to upgrade. Here's my help for anybody using one of these ancient dinosaurs. If you've got a good calculator, don't do what I'm doing next. This is just advice for people who have something from the 1900s here. Just put a bracket around the numerator. That's all. Yeah. Hey, oh, that's okay. I can keep my calculator then. All right. Is that one of mine or is that yours? What's that? Oh, yeah. Well, bracket 5 plus, I've got to use a bracket. You don't have to if you've got a fancy calculator. Root 33, close bracket, divided by 4. Anybody else get 2.69? Yeah? And then the other one, I'll just scroll back. I won't retype it in. I'll just push the arrow key over, arrow back over, delete the plus, change it to a minus, and I get negative 0.19. Did you get negative 0.19? There were two numbers that multiplied to something and added something. They just happen to be so ridiculous that no one's ever going to come up with them without a procedure like this. All right. But tell me, what questions do you have? Even the craziest, silly little step that you're like, what did you do there? Tell me. Because this might be the craziest procedure you've learned so far. It only has one upside. It's the same every time. Yeah, it's the same exact moves every time. So just by pure repetition, people who are willing to practice eventually go, okay, I got this. I can now complete the square. More time? Ben? Yes. Nice catch. Oh, I would have been so sad. If you had texted me after school, I think one of the examples is wrong in your video. I'd have been like, would have ruined my whole weekend. I might have had to redo the video at home. That's how crazy it would have drove me. Other great questions? Do you need more time? Yes and no. There will be a question that says solve by completing the square, but then on Monday we'll do the quadratic formula, which is the exact same thing. I'll show it. I'll go, this is the exact, so quadratic formula does the exact same thing. Yeah.
Is this last one?
I don't know. I just keep going. No, it can't be. It says A again. 3 more.
Where are you going? I can't. I need to walk in.
Find the zeros. What's different when it says find the zeros? Just that. It says find the zeros, make y equals 0, and now I'm solving by completing the square. Unless it factors. Does it factor? Negative 12 no, it doesn't factor. All right. Here we go. A little faster. I'm not to rush the lesson. 3 examples in 35 minutes, I got all sorts of time. But I'm not trying to rush it. I'm trying to inspire you that, like, if you're at this point going, he's done 2 examples in 30 minutes. I'm going to be doing this homework all through November. No, you just have to get better at it. That's all. Here, a little faster. A little faster this time, just to show it can be done. Common factor off the 6. And as I said, reduce fractions as you see them. Anytime you can reduce a fraction, you're making your life easier. Magic number? I don't know where I'm going to put this. Down here for now? Ooh, scary. I'll minimize it. I don't like not having it on the screen, but anyways. Okay. 1 over 2 divided by 2 squared equals 1/2 times 1/2 squared equals 1/4 squared equals 1/16. There's my magic number this time, 1/16. Shh. Distracting me.
Lock in, Leo.
What number multiplies by itself to give 1 over 16? But when you add it to itself, you get 1/2. 1 over 4. You can get it from over here. But you can also just go the square root of the 1 over 16. You can just go, okay, whatever the square root of 1 over 16 is. So that's the x plus 1 over 4. Reduce that beautiful fraction that's popped out of there. And then get a common denominator. I really want it to fit on that side. I want it to be over there. Okay, I'll just scroll down. Is this too far? I hope it's not too far. That's the end of completing the square. I'm not claiming that's easy. I'm just saying that's the same thing you've been doing in the other homework if you've been keeping up. The next stage is just isolation. By completing the square, I now have only one type of x term, so here we go. I'll show these steps fairly fast too. Not because I'm trying to rush you. I'll answer all the questions you want here. But you may find this side is a little more familiar. And I'll type these in. And you let me know which part you want to have questions about. There may be a zillion questions. -1 divided by 4 plus square root 19 over 48. What's happening over there? Actually, I don't care what's happening with it. Oh, stop that. Here's some good life advice. Just do what Reese tells you. That will work out best for you.
Try to pass the scores.
Right. Do what Reese tells you. I'm not rushing. I'm ready for your questions. Tell me. That's not working. Oh, that's no good. You're stealing my calculators. Did anyone else type this in to make sure I didn't make a mistake? Ben's back there typing in for me and loves to correct me. So. Tell me. Come on, there must be at least one question there. No way I'm that good, is it? That you're like, oh, I totally get that now. Which step do you want to talk about?
He's pushing him at bruises.
These sentences sound like wise things to say out loud as you're thinking them.
I was just telling you what he's doing because you give weird faces.
Because you're being weird.
You're pushing on me.
Oh yeah, he was.
How did I do? Did I give you enough time to copy?
I got negative 0.34. I got that too.
Yeah? Because I was using this other stupid oh, sorry. This other ancient calculator. Oh, stupid. Yeah.
I'll plug it in real quick. Mr. Tony.
No, I've put some batteries in a new one here.
I might be wrong. Mr. Todd, I got what you wrote down right there.
You think I'm right?
Yeah.
I'm feeling pretty good about this. I just retyped it in, yeah? Oh, the score between me and Ben is 1-1. Heading into extra innings here. It's good? Are you happy? No, you're not happy. Are you less sad? No. At least no, I'm not less sad. Sorry. It's good? More time here? Did I give you enough time? VC and Danielle have given up. They're like, that's it. I'm out.
I ain't giving up, Mr. Todd. Let's go. Let's do it.
The question said, find the zeros.
You just add 75?
Yeah, right. But I will carefully show the steps here. It said find the zero, so I set y equals 0. All of our procedures are based on having 0 on this side. So I move the negative 75 over. What would you like to do next?
Factor.
Try to factor. You're sitting in front of the thing going, please factor. You know, a day ago you're like, I hate factoring, and now you're like, just let me factor it so I don't have to complete the square. So I'll try it. It has a common factor. Yeah? And then it's, is there two numbers that multiply to 25 and add to 10? 5 and 5. This thing factors. You could write, therefore, x equals -5 or x equals -5. But I don't know if that's really necessary. So now you should have a question. So when should I use complete the square? Option 1, when it won't factor. Option 2, when you're told you have to do this question by complete the square. That's not really my move. On a quiz, if I say solve by complete the square, I'll make one that doesn't factor. You know, I'm not going to put you in that situation. I don't know if the homework always does that. I don't have the homework memorized. But if it says solve by complete the square, they're saying, I want you to practice by completing the square. Next question that you might have. What about this 3 out front? Does it matter at all? And the answer is no, it doesn't matter at all. It cannot make this equation equal to 0. Only the variables can make it 0. There's no way to make 3 into -3 or something like that. Only the variables can do that. And more on that in an upcoming lesson. Yes? But all you got to worry about is the factors that have variables in them. I tried to read your mind. What other questions do you have here? You could complete the square. You don't have to copy this if you don't want to. You're like, no, I got my ones that I have to complete the square down. I don't need another example, but here it comes. So it's not a mistake. Might be a waste of time. Factoring is usually faster. It's good. Other questions? Mr. Todd, is this what my life's down to? Spending my whole weekend doing complete the square, working on algebra? Only if you want to take U math courses. Yeah. More time here? My brain's screaming that I have one more to go. Is that correct?
These iPad kids.
The question said, find the zeros. That's why I'm doing set y equal to 0 at the start of each of these. Now what? Yes, I'm going to check if I can factor it. No question about it. For factoring to be able to accomplish anything, the 0 property has to be able to get in here, which means have a 0 over there. So this has got to move over before I try anything. And whatever your procedure is, maybe you try decomp at this point and you go, okay, 2 times 4 is 8. Two things that multiply to 8 and add to -5. 1, 8, 2, 4, -1, -8, -2, -4. I don't know what procedure you're using, but it won't be long before this doesn't factor. I need something else if it doesn't factor. And it's complete the square. Here it is. Here we go. A little faster again, but I'll pause for questions. Trying to end the second half of this go. This doesn't have to take forever once you get good at it. I will pause for questions there. I'm just going to start the next side and then wait for a while for you to catch up, process, and ask questions. Do not take the fact that I'm writing those fast as me implying, oh, this should be easy now. That is not what I mean at all. I'm just trying to show that with a little practice, you don't have to be disheartened by the amount of homework. It can go faster. The first couple that you do will probably take a while, and then things will move along. Hopefully. But something else is going to happen yet. This lesson isn't over. So I am going to wait until you're caught up and have your questions answered on what I've done so far. Yeah. Do you have questions? Do you need more time to get to there? Okay. Finish it off. Negative 7 over 8 divided by 2. Trying to find a spot there that I can fit a little bit more in here. All right. What's the square root of negative 7? Math error. Yeah, you can't square a negative. Let me just step ahead 1, 2, 3 courses. You can square a negative, but we just need some different numbers than we have available to us, okay? For our purposes, we're quite happy. I'm back to grade 11 now. We can't square negatives, yeah? There's no answers here. Is that possible? Is it possible for a quadratic to have no zeros? Can a parabola have no zeros? I tried to prepare you for that the other day. It is possible. You get through all this and find out, oh, there's no solutions to that. Let's see a picture before the lesson completes. And I'll come back to this if you still need copying. I'll come back to this, and I'm going to graph this thing. Y equals 2x squared. I forget already what it was. Minus 5x plus 4. That's what I was working with. Do you see it? All that work to find out, oh, this doesn't have any zeros. No. If it's negative inside the square root, that just means, oh, no zeros.
So can you tell that from like further up, or do you have to?
Yeah, you probably could have noticed. When did I notice? Because I haven't taught 11U in a long time, so I don't remember the exact examples. But I noticed right here that we might be in trouble with the 4. Because when it came over, it was going to be negative. I wasn't positive, but the 4 was positive, and that made me wonder. Then I knew for sure here. I was like, no, it's not going to go. It's going to go over in square root, and then it's not going to happen. Right? So